Good morning. We are about to start chapter 6, and chapter 6 has to do with exponents. I know it says pre-7-8, but chapter 6. So, exponents, the basics of exponents. An exponent means that I have a number, and I'm going to multiply it many times. I might multiply it twice, that's to the power of 2, squared. I might multiply that number by itself 3 times, that'd be called cubed. Or 4 times, or 5 times, etc. So here are the things that we need to know. The base is the big number that you'll see. The little number up above is called the exponent or the power. So, some basics. 4 times 4 times 4 means 4 to the third power. You put a little 3 up there because I'm multiplying it 3 times. 7 times 7 times 7 means 7 to the third power. Now, some of these are easy to multiply. Like I can do 4 to the third in my head. 4 times 4 is 16. 16 times 4 is 64. So when numbers are small, I can say, oh, 4 to the third is 64. I know that because it's not too large of a number. But no teacher is ever going to ask you to do something like 4 to the 7th power in your head. That's way too big. So 7 to the third, there you go. Next, I'm going to do 2 to the third. What's 2 times 2 times 2? I can do that in my head. 2 times 2 is what? What's 2 times 2? 4. What's 4 times another 2? 8. So it's 8. 2 times 2 times 2. Now 8 to the 5th, nope, I'm not going to make you do that. If a teacher let you have a calculator, then you could do it. But again, I'm just going to leave it 8 to the 5th. There's no way I'm going to make you multiply that up. Now let's talk about the word squared. How would I write 7 squared? What would I put? A what and a what? A 7? Yeah, I heard you. And a 2. Good. Let me make sure this is not bleeding through. 4 cubed. What does cubed mean? A cube is a 3-dimensional shape. I don't even have one in the room. It's a box. I don't have a box. Okay. It's a cube. 3-dimensional. So a 3 is the exponent we use for cube. 3-dimensional cubed. A square is 2-dimensional. That's why we use the word squared for a little 2 exponent. Okay. 4 with a little 3. All right. Now on the margin, I already asked you to do this, so this should be done, but I will go through it really quickly. 1 squared is 1. 2 squared is 4. 3 squared, do not ever say 6. 3 squared is not 6. Students do that. They're like, oh, 3 times 2. No, it doesn't say 3 times 2. It says 3 squared, which means 3 times 3, which is 9. And I think this is still a pen. Okay. 4 squared. Just tell me out loud. 4 squared. 16. 5 squared. Wake up high. 5 squared. Out loud. Everyone. Oh. 6 squared. Thank you. 7 squared. Thank you. 8 squared. Good. 9 squared. 81. 10 squared. 10 times 10. 11 squared. 12 squared. 144. Okay, these numbers need to be memorized. You also need to memorize the part that I wrote on the board where it says, the square root of 25 equals 5. The square root of 36 equals 6. The square root of 49 equals 7. things like that. You need to know it backwards, the square root portion. So I best write that, huh? The square root of 64 equals 8. The square root of 81 equals 9. The square root of 100 equals 10. Let me do the ones up above. The square root of 16 equals 4. The square root of 9 equals 3. The square root of 4 equals 2. The square root of 1 equals 1. And these are all implied. There's little 2's right here. But I'm not going to write those little 2's, but it's implied that there would be like a little 2 in that index root position. All right, common. 2 cubed. 2 times 2 times 2, what is it? 8. Can I have new volunteers, please? 2 to the 4th. That one's on the board. I had you write it. 16. 2 to the 5th, which is like 16 times 2. 32. Okay, 3 to the 3rd. Take a break. 3 to the 3rd. 27. 3 to the 4th. That's on the board. Say it again. 3 to the 4th. It's 27 times 3. 81. 4 to the 3rd. 4 times 4 times 4. 64. 5 to the 3rd. 5 times 5 times 5. 125. Good. I say common because they come up a lot in math. All right, number 1. 2 cubed. 2 cubed. How do I write it with an exponent? A number and an exponent. What do I put? Two with a what? A little 3. Number 2, 9 to the y power. I don't know the power, but it's a y power. So I put a what? A 9 and a little y. Okay, number 3. 3 times 3 times 3. Write it using an exponent though. Don't write 27. Write it with an exponent. So I would put 3 to the, with a little, not the y yet. We'll do that next. How many 3's are there? There's 3 of them. So it's 3 to the 3rd. And then y. Y to the squared. Good. So 3 cubed y squared. You need to know the vocabulary for this. Number 4. I only see 5. And it's all by itself. So it's like 5 to the 1st. But nobody writes a 1. Just a 5. How many x's do I have? 1, 2, 3, 4, 5. X to the, and you put a little 5. 5x to the 5th. Now, 4g, the whole 4g, I wrote 3 times. The 4 and the g have to stay together. So I'm going to put that the 4 and the g stay together in a parentheses. Because there's a 4, a 4, and a 4, a g, and a g. So, 4g to the 3rd. All right, now I'm asking you to evaluate. So we're actually doing the math. Evaluate means solve it, work it out. 10 squared is what? Is it 20 or is it 100? 10 squared. 100. 10 times 10. 6 to the 3rd. I actually have to do it out, you guys. So 6 times 6 times 6. 6 times 6 is 36 times 6. So just like do it out on the side of your paper. 6 times 6 is 36. 6 times 3 is 18, 19, 20, 21. 216. Nine to the third. 9 times 9 times 9. Well, 9 times 9 is 81. Times 9 is what? So, say it again. 729. All right, number 9. Evaluate the expression for the given value. 4 to the nth power, where n equals 3. So I'm substituting. Plug it in, plug it in. 4 to the third power. And it says evaluate. Evaluate means solve. 4 times 4 times 4. I did that down here in my common. It's 64. Number 10. X to the fifth when x equals 5. So I'm going to put a little 5. Well, I'm going to put a 10 raised to the power 5. And you guys, I don't know if you've learned about scientific notation in science, but if there's a 5 as the exponent and the number is 10, that means that there's 5 zeros. A 1 with 5 zeros. 1, 2, 3, 4, 5. And then I do my comma, as always, count back 3, 1, 2, 3, comma. 100,000. Number 11, x plus y squared. So instead of x, I'm going to put a 5. Instead of y, I'm going to put a 3. 5 plus 3 squared. What does order of operations say that I do first? Parentheses. So add the 5 plus 3 first. That's going to be 8. 8 squared. 8 squared is not 16. Do not say 16. It means 8 times 8, which is what? It's on the side of your paper. 8 times 8. 64. Thank you. Now I'm replacing the variables with the given numbers. M is 25. 25 minus n squared. N is 4. 4 squared. Do not do 25 take away 4. You need to do exponents first. You need to do 4 squared first. This is 16. 25 minus 16. So 25 minus 16 is 9, yeah? Okay, so with this, these are the basics of exponents. We're now going to talk a little bit about fractions. I'm not going to give you, so as you can see, there's like 1 through 10, 1 through 10, multiplication and division. Okay, I'm going to go through and I'm going to do the first one of every example for you. First one of addition, first one of subtraction. So let's start with that. Adding. Here's the notes we need to know. Find a common denominator. Find a common denominator. I have 10 sixteenths plus 2 eighths. Think of a big number that they both go into. It can be one of those numbers itself. And since it's horizontal, I'm going to have to make it horizontal. As a little girl, I was taught vertical up and down, but it's okay. 16 and 8, they both go into what big number? What multiple? Common denominator of 16 and 8. No one knows? Well, it's not 2. 2 is called a factor. That's too small. 16. So I'm going to make 2 new fractions. The 10/16 I need to make into a fraction that has a 16. Well, it already is a 16th. So I don't change the 10/16. But the 2/8 I need to break up into 16ths. What did I do to 8 to make 16? Okay. 8 times what makes 16? 8 times 2. So I changed the denominator and the numerator. 8 times 2 is 16. 2 times 2 is 4. My 2 new fractions are 10/16 plus 4/16. Since they have the same denominator, I can now add straight across. 14/16. And simplify, reduce this fraction by 2, yeah? 7/8. For subtraction, I also find the common denominator. All right. 7/9 and then 3/27. What's the common denominator of 9 and 27? Nine and 27. What does 9 go into that 27 also goes into? A bigger number, not like 3. 27. Make them both into 27. So now I'm changing fractions. 7/9 needs to come something 27ths. So 9 times what makes 27? 9 tripled, right? Times 3. So I'm going to do 9 times 3. I also need to do 7 times 3. Whatever I do to the denominator, I do to the numerator. I'm making this into a 27th fraction. Well, the numerator, 7 times 3 is 21. Minus 3/27. Oh, it's already done. 3/27. Great. 18/27. Subtract. 21 take away 3. Simplify, please. What goes into 18 and into 27? What's small number? 3. Thank you. 18 divided by 3 is 6. 27 divided by 3 is 9. Oh, I can go even further. I should have picked 9. Anyways, the answer is 2/3. So that's adding and subtracting. Here's the ones I want you to do for adding and subtracting homework. Actually, I'll tell you after. I need you to pay attention to multiply and divide. I'm going to multiplication. You're lucky because all of my fractions here are just plain old fractions. I did not give you mixed numbers. If I would have given you mixed numbers, you would have had to change them into improper fractions. The rules for multiplying are multiply straight across. Multiply straight across. Sorry. These are going to be really large numbers. I can cross simplify if I want. Like 5 and 20 can cross cancel, so I can do that. It would make my life easier because I don't want to do 20 times 16. So 5 and 20. 5 goes into itself once. 5 goes into 20 4 times. Now it's okay for me to multiply straight across. 3 times 1, 3. 4 times 16, 64. Division. Switch the second fraction. Let me show you why. If I have 1/2 divided by 5/8, it would look like this. Let me do it on the top of your paper. 1/2 divided by 5/8. If it were a true division problem, I would have a numerator and a denominator. The reason that I switch only the second fraction is because in this denominator, I can't have 5/8. So I need to get rid of the 5/8. I get rid of the 5/8 by multiplying by the reciprocal, 8/5. Whatever I do to the bottom, I do to the top. Because now, 1/2 times 8/5, 5/8 times 8/5. This denominator is now canceling out because I multiplied by its reciprocal. So the reason that only the second fraction gets flipped is due to this. If you wrote it as a numerator denominator, you would get this. So now, it's a multiplication problem with 8/5. And I can multiply straight across. 1 times 8, 8. 2 times 5, 10. 8/10. Divide by 2. Simplify fractions. 4/5. Okay. Number 2, I'll just set it up for you. 2/16 times 14/5. So you switch the second fraction and then multiply. Okay. So you're not doing 10 on every single one. We're just going to do the first 6 of every single one. So you're going to go to 6. All right, I'm going to stop the recording.